is a non-proportional linear relationship represented by a graph or equation. Think about this question during the lesson. The middle school student council is organizing a dance and has $500 to pay for a DJ. DJ Dave charges a setup fee of $125 plus an hourly rate to play music. DJ Dave will charge $200 for 1 hour and $425 for 4 hours. How can the student council determine whether they can afford to have the DJ play for 5 hours? You can begin by using a graph to plot the total costs for DJ Dave for 1 hour and for 4 hours. Draw a straight line through the points. Find the initial value or y-intercept and the rate of change or slope. The initial value or y-intercept is 125. DJ Dave charges a $125 initial fee. Now, use 2 points on the line to calculate the slope. The slope is the rise or difference of the y-coordinates divided by the run or difference of the x-coordinates. DJ Dave's hourly rate is $75. Write an equation to represent the total cost for DJ Dave for any number of hours. The total cost is equal to the hourly rate plus the initial fee. Using the data from the problem, write the equation y is equal to 75x plus 125. This equation is in slope-intercept form. Y is equal to mx plus b, in which m is the rate of change or slope, and b is the initial value or y-intercept. You can now evaluate the equation to find the total cost for 5 hours. Which variable has a value of 5?
Select your answer.
The value for x is 5. X is 5. 75 times 5 is equal to 375. So the total cost is $500. The student council can afford DJ Dave.
Write a linear equation in slope-intercept form for the graph shown.
The y-intercept of the line is 2. The slope would be, if we look here at the lines they have drawn, our rise would be about, what is this? 3. And our run would be 1, 2, 3, 4. And so that's our slope. So our equation would be y is equal to 3/4 x plus 2.
A saltwater solution is cooled to -6 degrees Celsius. During an experiment, the mixture is heated so that its temperature rises at a steady rate. Write an equation to represent the temperature y after x minutes.
Okay, so we have to write an equation first. So saltwater solution is cooled at -6 degrees. They've already placed the line, so we just have to write the equation. So our y-intercept, let's start with that. Our y-intercept here would be 6. Because this is -6, because that's where it crosses through the y-axis. And then let's take a look, rise and run. So you look at the 2 points they have here. So our rise would be the 4, and our run would be the 2. So our slope would be 4 over 2, which would be 2 over 1, which would be 2. So that'll be 2. So it'll be y equals 2x plus negative 6. Let's see. Yes, that is it. So that will be our equation that we would have.
Graph the equation y equals negative 4x plus 3. The first step is to use the equation to identify the y-intercept, which is 3. Plot the y-intercept at the coordinates 0, 3. The next step is to use the equation to identify the slope, which is the coefficient of x. The slope is negative 4, or negative 4 wholes. A negative slope means that the line is decreasing. To locate another point on the line, start at the point of coordinates 0, 3, and then go down 4, and right 1. Plot the second point at the coordinates 1, negative 1. The third step is to draw a line through the 2 points. This line represents the equation y equals negative 4x plus 3.
Part A. What is an equation for the line shown?
Okay, so the equation for the line shown, let's start with the y-intercept. Let me just write down the equation. So we want to end up with y equals mx plus b. So let's start with our y-intercept. Our y is going to be here, which is 2. So I'm going to replace the b with a 2. The x stays there, the y will stay there. Now I need to find my slope. So I pick a point on the line. So if I choose here, my rise would be 1. And my run would be, let's see, my rise would be 1, and run would be 1, 2. So it'll be 1, 1/2. So our slope would be 1/2 times x plus b. So y equals mx plus b will be this.
Part B. Graph the line with equation y equals 1/3 times x minus 5.
All right, so I'm going to try to use this Desmos graph. Okay, so the equation is here, and my y-intercept is 5. So I need to find, and it's going to be negative 5 because that's a minus in front of it. So my line needs to go through the number 5. So how can I move? There you go. All right, so 5 would be, I'm guessing about here. Yeah, about there. So there's my 5, my negative 5. So that's my y-intercept. And then my slope needs to be reflected 1 over 3. So my rise would have to be 1 and then over 3 spaces. So I'm going to have to move this. Oh, wrong part. How do I move this? Okay, I'm going to have to play around with this some more. Let's see. I put this here and then I just move like, perfect. Okay, so I need to have it where my slope is correct. So again, it's 1 over 3. So it'll go up 1, which is a rise, over 3, 1. Well, no, this will be 1 here, 2 here, 3 will be here. So about there. So my line should look like this. So my slope, or sorry, my y-intercept is the negative 5, and my rise is up 1 and over 3. 1, 2, and 3. So that's what your line should look like based on the equation given to us.
Graph the linear relationship.
So, okay, so we gotta graph this. Step 1, plot the points on the table into the graph. Step 2 would be to draw a straight line to connect the points. Okay, and that's it.
Zoe and Masio ride their bikes on the Pinellas Trail. Write an equation for each rider to find how far from the trailhead they are at X hours.
Zoe's ride log, she started at 3.5 mile marker and she rode an average of 10.5 miles. So the slope and y-intercept is what we need to determine based on her description. So the slope will be her average speed and her y-intercept, will be her starting point. So she started at 3.5 and then her slope will be the 10.5 miles per hour. So this will be the equation based on her description. Part B, this is for Masio. So he has his on his phone. And so from there, we have, we're determining his slope using the equation y2 minus y1, x2 minus x1. So they used 2 of the points here and subtracted them. And then we got the y-intercept. The y-intercept is the value when x is 0. So the y-intercept, the x is 0 here, so our y-intercept is 0.75. And then the slope is what we did here, and that equals 9.5. So Masio's distance from the trailhead at x hours is 9.5x plus 0.75.
Write and graph a linear equation given the table of values.
So we have this table of values, and we have to write the equation and graph it. So let's start with the base y equals mx plus b. So that's what we're plus b. So that's what we need to have. So our y stays the same equals. So we need to find our slope and y-intercept. So the y-intercept is where the line crosses through the y-axis, but we have to also graph it. So let's start with finding the slope. So the slope is going to be using the y2 minus y1, and let's write this here. Okay, so y2 minus y1 over x2 x1. So we choose 2 points. All right, so I'm going to choose these 2 points here. So my my y. So my y2 is going to be 2 minus the 1.5. My x2 is going to be the 2 minus the 1. So I get 2 minus 1.5 and 2 minus 1. This will be 1.5 over 1. And so my slope would then be 1.5. Alright, so I have my slope, and then my y-intercept has to be where y intersects the y-axis. So the y-intercept is determined if you have your x at 0. So if my x is at 0, 2.5 is my y-intercept. So let me make it a decimal. I could type it in there. So it's 2.5. I forgot my x. So that will be my equation. And now I need to graph this equation. So my y-intercept and 2.5. That would be 1, 2, 3, 4, 5. So 2.5, 1, 2 be like right in the middle here. That's our y-intercept. And then we have to show our slope. So our slope will be going up 1 and then over halfway through. So be like this, half, and then over. Yeah, it'll be something like that. But let's see. Double check everything. Ba-ba-da-bum-bum. So I'm realizing now that when I wrote out my formula that I did not write one of them in the right place. So let me just redo it really quickly just so make sure this is all right. Okay, so I chose the points. I chose these points here, these last two here. So my y2 would be 1.5 minus y1, which would be, excuse me, 2 over x2, which would be 2 minus 1. And I think I had these switched the other way before, so I just wanted to make sure I clarified. So this would be 1 still, and it'll still be 1.5 as the answer, but it's going to be negative 1.5 because this 1.5 is, smaller than this negative 2 here, so that it's going to be negative. So my answer over here would be negative 1.5. So that changes my graph. So now instead of going this direction, my graph will be going this direction. It's going to be going up, still rising, and then going to the left a half. So it'll be like just the opposite direction of where I had it. So still the 2.5, and then I go rise 1.5, 1.5, and then over 1. About there. It's not perfect, but about there-ish should be the line.